All right, let's see. We want to start with 6.
Yep.
Okay, let me let me blow that up just a little bit. Not much. All right. I have some drawing space. So, what's the first thing you can do on 6? Always factor in the priority of the priorities, or always use a priority. Always.
Right. So, greatest common factor then, right?
Tell me what it is. Don't ask.
3.
Okay, what's the next
So,
line?
so it's 3, parenthesis, x squared minus 16, parenthesis.
Good. Now, can I do anything more to that?
You can split up the x squared minus 16.
Into,
X minus 4 and then x plus 4.
good. And that's your final answer. Okay, how about the second one?
All right. So,
In other words, you cannot do greatest common factor. It's not difference of perfect squares, which means
right.
that's the normal quadratic factoring.
Okay. So, I guess, so A times C is 4. And then the B is -3. So,
In other words, you've already figured out that it doesn't factor normally.
oh yeah.
Okay, when it doesn't factor normally, then you have to use the quadratic. Okay, tell me what the quadratic's going to give us.
So up to B, so 3. So yeah, x equals 3, plus or minus the square root of 3 squared, or is it -3 squared?
Doesn't
Or
matter
just
because it turns positive always, whether it's negative or positive.
okay, so 9, minus 4 times 1 times 4.
All over what?
2a.
2. Okay, now simplify that.
So the discriminant gets turned into 9 minus 4 times 4, or 4 times 1, so 16. 9 minus 16,
Okay,
which is -7.
keep going.
So
That's what you have to write differently right there.
yeah, so that can turn into 7i, square root of 7i.
Okay, so it's 3 plus or minus square root of 7i. Make sure that i is outside the radical,
Right,
all over 2. And
right.
that's your best answer right there. Okay. And incidentally, when you look at some of these and you determine that they can't be factored in a normal way, this confirms that. In other words, if there was a couple of factors that we missed, let's say that turned out to be x minus 2 times x minus 2, okay?
Okay,
Then we would end up getting whole numbers over here when we use the quadratic. The quadratic will still work, and it'll give you the proper answers you would have gotten had you factored it. So you don't need to spend a whole lot of time figuring out whether you can factor it. Once you come to the conclusion you can't factor it, go ahead and go into the quadratic. If you're wrong, you'll see the right answer anyway. Won't cost you anything. In other words, the quadratic formula always gives you the right answer, whether you can factor it or not.
Okay.
Okay, how about 8?
So you can greatest common factor. So
what's the greatest common factor?
actually 9 doesn't go. Oh, 3.
No, 3 doesn't go into 16.
So there isn't one.
Okay, what's next on your list after greatest common factor? Next on your priority list. Once you check for greatest common factor, next thing you should always check for is difference of perfect squares.
Okay. So
Qualify?
So yes.
Okay, to what?
So it's 3x minus 4.
In other words, it's the square root of that minus the square root of that. That's this term every time. And then the second term is just the conjugate. You don't have to do any math to get the second term. The whole key to difference of perfect squares is figuring out what the square root of each term is. And guess what? It doesn't actually have to be difference of perfect squares. It's difference of squares. DOS. Factor this for me. Not this one, but the one I just wrote. X minus 7. Factor that. There's no greatest common factor.
Right.
It's not difference of perfect squares, but guess what? It doesn't have to be difference of perfect squares. That is true.
Okay.
Okay? Although, I would say at this level of math, you're never going to get one that needs you to use DOS. You're always going to get DOPS, difference of perfect squares. But the fact is that you don't really need difference of perfect squares.
Okay.
To factor. Okay, how about this one?
So,
I apologize for keep coughing. I have the flu.
that's fine.
I was going to be able to do this session, but you're my first of the day, so I think I can get through one at least.
Yeah. So, you have to do the quadratic formula.
Don't give up on factoring so easy. Only because it's so much easier than the quadratic formula that if it can be done, you want to find it. Let's try factoring this. Step 1.
So,
What's the first step in factoring? Split the x's up. Split the x's up. Those have to be split up.
okay.
So what's going to multiply together to give you 2x squared?
X squared, or 2x and x.
Okay. That's first step. We split the x's up. Second step.
I don't know.
Determine both signs.
So one's positive, one's negative.
Okay. And in this case, plus minus is not the same as minus plus, so I have to allow for both of them.
Okay.
Now, we need factors of 4. There's only 2 of them. We got to get to 7 in the middle. Where's the 4 got to go? Or where's one of the factors go? 2 and 2 clearly isn't going to work.
Right.
Why? 2 and 2 will never get you to 7. The whole object at this point is, can we get to 7x in the middle? That's what you got to be thinking. Well, how am I going to get to 7x? I got to have the 4 multiplying the 2, do I not?
Yeah.
And it's a plus 7x. So I got to have that. That alone, that's 8x. So that's pretty good to get to 7x. Well, if I do the plus 4, then this got to be minus 1. And the inside is minus 1x. Totaling 7x. So I could factor it.
Okay.
Now tell me the solution. In other words, we just factored it. We didn't solve it. It says find the solutions. Factor, then find the solutions. There's a problem with this question. This is the solution.
Okay.
But that's not what he meant. Your teacher meant that these were all equations equal to 0, and after you factored them, you solved them. So if that's equal to 0, then solve it.
So
you have 2 things multiplied together equals 0.
right.
So what does that mean? Name me 2 numbers that multiply together that equal 0.
0.
The key. One of these has to be 0. The only way you can do it. You can't name me 2 numbers other than 0 that multiply together to equal 0. So once I have 2 things multiplied together equaling 0, then I just set each one of them equal to 0 and solve. What's the solution to that part?
So 2x equals 1, so x equals 1/2.
Okay, now set the other one equal to 0. X plus 4 equals 0. What's that part?
X is -4.
All right. There's your 2 solutions, and remember, when you have a quadratic, you're usually always looking for 2 solutions. Now, why did I say he made a mistake? Because you can factor each of these, but you can't solve something that's not an equation. Only thing you can do is factor it. This one factored to 3x minus 4 times 3x plus 4. That's all you can do. There's no solution because he doesn't have an equation. If he'd have said all of that equals 0, now you have an equation and you can solve for it.
Okay.
There's a difference. It's subtle, but there's a difference. In other words, these are expressions. He should have left that off. He should have just said factor the following, which is all we can do. We can't find solutions because he hadn't given us an equation.
Right. All right.
So, number 10. Any idea on how we're going to solve this?
I don't know.
Well, if I did the first thing you think of, I expand that. That doesn't help. I still don't have a clue as to how to come up with H and K. So that's not the way to go. If I gave you this and I said, tell me the vertex, where's the vertex? Forget the left side for the moment.
It's at HK.
Okay? So, that's vertex format. How do you convert a polynomial like that into vertex format? I want to manipulate that, and I want it getting to look like x minus some number squared plus another number. Then I'll know what h and k are. In other words, if I can get this looking exactly like that, then I'll have my answers. And the way you do it is the same way you take any polynomial and you put it into a format. You complete the square.
Okay.
How do you complete the square on the left side?
So,
No.
hold on. I just did this. So find the discriminant, which in like through the quadratic formula.
No, not the way to, that has nothing to do with completing the square. I'll go through it one time because you're going to have to do it again multiple times on 11.
Why?
That is the same as that, correct?
Yeah.
Okay. Now, I need to complete the square inside the parentheses. How do you do that?
Divide the middle by half. Yeah, in half.
You got it. Now keep going.
So that's 3.
Okay, and then what do you do?
So that's, then square it.
Okay.
So it's plus 9.
Okay. Now I just changed everything. I just added 9. How do I counterbalance that?
So you multiply it on the other side too.
No, there's no other side here. There's one side only.
So you have to add 9 to 15.
No, you got to subtract 9 from 15. There's one side only. So the fact that I added 9 means I got to subtract 9 from the same side.
Okay.
And the fact that I completed the square now allows me to write that as some x minus h squared. What is that?
So it's x plus or minus 3 squared.
Now you got to combine those two numbers.
Plus 6.
Okay, this right here is identical to this, just in a different format. But it happens to be in this format precisely. So tell me what h and k are.
3 and 6.
You've got to be able to complete the square. You just can't go anywhere in algebra without completing the square.
Okay.
Scroll down a little bit. So they want us to use 3 methods to solve this. Do the hardest one first, completing the square. In other words, if I can complete the square on that, I will have it in Vertex Format. And then I'll know where to start my graph. I don't have any idea where to start my graph now because it's in standard format. That's standard format. If I want to graph it, I got to get it in either Vertex Format or X-Intercept format. And X-Intercept format's much harder to get it into. Unless you can factor it. Actually, in this case, you can. But it says complete the square. It doesn't say put it into X-Intercept format. You don't complete the square to put it into X-Intercept format. But, so how do I complete the square?
So, outside the parentheses is negative 32.
Okay, what's inside the parentheses so far?
X squared minus 4x.
And always leave room because you know you got to add something in there. Okay? But so far, what I've written is identical to what we started with. And that's what you always want to think of when you're completing the square. Make sure that you end up with the same thing you started with. You can manipulate it algebraically. You can't change it. You can't make that 31 all of a sudden. So now what?
So it would be plus 4 because if you divide 4.
Yeah, that's all right.
So
give me that number. You don't need to explain it. Okay. Now what do I got to do?
Subtract 4 from negative 32?
Yeah.
Or add?
In other words, I can't change that. So if I added 4, I got to subtract 4. If I was working with the other side of the equation, then I might have to add 4 and add 4 to the other side. And every now and then you do complete the square where you have the other side of the equation, which is what you balance. But not here. Vertex Format, everything. Remember what Vertex Format is. It's y equals x minus h squared plus k. Everything is on the right side of the formula. So I don't have anything on the other side of the formula that I can balance. I only have my ability to balance the same side. Now rewrite that in Vertex Format. You're now ready to write that in Vertex Format.
So it's y equals x minus 2 squared minus 36.
And now tell me how to graph that.
So the vertex is at,
Excuse me. Go ahead.
it's at 2, negative 36.
Okay, interesting that they gave us a graph that didn't go down there. What's going on here? All right. Well, so the vertex is, we'll just call this the vertex. Okay. Now, I can't graph it from just the vertex. I need other things.
Right.
Well, what's the two best points to get?
The X-Intercepts.
Okay. Notice we can factor this fairly easily. And guess what? Once I factor it, I got my X-Intercepts. Now I'm done. I'm done graphing it. Once I get my two X-Intercepts and my vertex, I'm going home. Okay, so how does this factor?
So it would be negative 4 and 8. So X or X minus 8.
Negative 8. But I would prefer you to do it in 3 steps. In other words, I would prefer you to split up the x's as the first step, determine both signs as the second step, and then the third and fourth steps will be easy. Rather than you did steps 2 through 4 all in one step, which is fine if you can do it every time, but I doubt that you can. So you need to follow a method. Okay. Now, if I'm looking for x-intercepts, I set all that equal to 0 because when I'm on the x-axis, y is equal to 0. So whenever my curve is on the x-axis, y is equal to 0. That's why I set it equal to 0. So what are my two x-intercepts?
4 and negative 8.
Nope.
It's negative 4 and 8. Because
you have to set each one of those equal to 0. And now I can draw it. We know it's a parabola. So when you have a parabola, if you can put the vertex and the x-intercepts, 3 points define a parabola. That's all you need. Okay. So we completed the square. We didn't use the quadratic formula. Let's use the quadratic formula. Now it's interesting that it says solve by graphing, but in order to graph it, we had to solve it. So you can't solve by graphing if you have to solve it in order to graph it. So the quadratic formula, apply it to this.
So x equals 4 plus or minus the square root of 16 minus 4 times 1 times negative 32 all over 2.
Okay. What's the discriminant equal to?
So
Use your calculator if you have to.
128. So minus 16. 112.
No. When you are solving for these discriminants, it's very easy to make a mistake. The way I tell everybody to do it, in this order, is to figure out that first. Not counting the negative sign in front of the 4. That's a subtraction sign. So what is 41 times negative 32?
Negative 128.
Okay, negative 128. Now do the rest of it. What is 16 subtract negative 128?
144.
Okay, what's square root of 144?
12.
What two answers does that produce?
So x equals 2 plus 6, and x equals 2 minus 6.
Which is, what answers does that give you? Or your teacher never accepts that answer. 2 plus 6. You give that answer, you're losing points.
Yeah. So 8 and then negative 4.
Same two answers we got when we put it in Vertex Format.
Okay.
Excuse me. Same two answers we got when we factored it to find the X-Intercepts. We got 8 and negative 4. So factoring it always gives you the same answer as you get from the quadratic formula. Okay? Now we can graph it. We really couldn't graph it until we did this other stuff first. Unless they wanted you to use your calculator to graph it, and I don't think they did. So once I completed the square, that gave me the vertex. Once I factored it, that gave me the 2 zeros, or applied the quadratic formula, that gave me the 2 zeros. Once I have the vertex and the 2 zeros, then I can graph.
All right.
Okay, apply the quadratic to this. Start by telling me A, B, and C.
So A is 3, B is negative 5, and then C is 5.
C is wrong. Before you can apply the quadratic formula, one side of this thing has to be 0. And it isn't right now.
Oh, so it's 3.
Okay.
C.
Now solve it with the quadratic formula.
X equals 5 plus or minus square root of 25 minus 4 times 3 times 3 all over 6.
John?
So 9 times 4 is 36.
Okay.
And 25 minus 36. Negative 11.
Okay.
So x equals 5 plus or minus this, or square root of 11, and then I, which is outside.
Okay.
And then over 6.
There's your two answers. Remember, in fact, whether you're factoring or using the quadratic formula, you always got to get one side 0.
Right. So I will real quick take a picture of the second page.
Okay. Or is it something you could verbalize?
Not really.
Okay.
Okay. It's sending. So, what? Why don't you send it? Okay, it's sent.
Yeah, there's no point in me even checking until it says sent on your end. Try it again. You got to be very still when you take a picture. If you are shaking at all, it comes out like this.
I thought she started watching in the kitchen.
Are you retaking it, Demetrius?
Yeah.
If you're sending an Apple iPhone, you need to send it as a large image attached file.
Yeah, I'm not. I'm sending on a sample.
Okay. One of my few students who has a Samsung, which is what I have.
All right, it's sent.
On a Samsung, I never know how to tell people how to do it on an iPhone. It's slightly different. You know that. You have to attach it as an image. Where do we want to start?
13.
Okay. Windows Ink workspace does not want to work. There it goes. All right. Graphical solutions are not really very useful. I understand why they teach them to people, but you're never doing it graphically unless it's a question on a test. Why? Because you can't read the answers that accurately. I mean, if the answer happens to fall right there on a grid mark, then you can read it. But what if it falls somewhere in between a grid mark, like there? So graphical is pretty worthless for accomplishing anything. It's just to demonstrate to you that you can do it algebraically or graphically, and they have to agree with one another. Now,
Yeah.
you're not going to know the exact answers from graphical, but you'll certainly know approximately where it is, and that will tell you whether your algebraic works or not. How did I solve that algebraically? The system of equations.
So
They solve systems of equations. Two methods.
Substitution or elimination. So this one could be
Which one are we going to use here?
substitution.
Okay. Because we've got not only one, but both equations are determined as one variable. In other words, they're already solved for one variable. Whenever you even have one equation solved for one variable, and it doesn't matter whether it's y or x, if you've got one equation solved already, then substitution always works better. Now in this case, where they give you both equations are solved, what's my next step that I'm going to write? These are the same y's. That y is equal to that y because we're in a system. If it wasn't a system, I wouldn't be able to say that. But we're in a system of equations. I know those y's are equal to one another. So what can I write?
7x plus 15 equals 2x plus, or x squared plus 2x plus 1.
Okay, now solve that.
So subtract 15. So 7x equals.
Which side are we moving everything over to? Right or the left?
Right.
Correct, because I want to leave that the same. If I had to move that to the left, it would have a minus sign in front of it, and that makes it very difficult to factor. So you always want your x squared term to have a plus coefficient. Okay, so after I move everything that's on the left to the right, what do I get on the right?
7x equals x squared.
No, just do it all at once. This is one of the times where I want you to do both steps at once. Because one is a variable, the other is a number. You're not going to get them mixed up. So when you subtract 7x from 2x, what do you get?
5x.
You get minus 5x.
Yeah.
And now do the 15, move it over.
So minus 14.
Okay, now factor that, or at least give it a shot. You should always give it a shot before giving up and going to the quadratic formula. Especially when it says end algebraically, you're pretty sure you can factor.
Yeah. So it's x on both sides, and then they're both negative.
If they were both negative, what would the constant be? Remember what factoring is. Factoring is the opposite of foiling. In other words, if I gave you two linear factors and I said multiply them together, you would FOIL them together, right? And the very last step of FOIL is where you multiply this number by this number, producing this number.
Right.
So how do you get a negative 14? You can't get it if they're both the same signs.
So a negative, or yeah.
And in this case, plus minus is the same as minus plus. When I say in this case, it's because these coefficients of x are the same. Whereas the last problem, we had a 2x and an x. Those are not the same coefficients, so we had to allow for a plus minus and a minus plus. Since these are the same, as all we have to allow for is 1, plus minus. Now, what's the third step? Trust me, you will be much better off if you do these in steps, as opposed to the way every student wants to do them. which is to try to solve it in one step instead of 4 steps.
So
factors of 14 that do what?
add to 5. Or
Subtract, because of that right there. If that was a plus, then it would be correct. They would have to add to whatever this number is. But as long as this is a minus, then factors of 14 have to subtract the 5. Not the negative 5, to 5. So give me factors of 14 that subtract to 5.
7 and -2.
7 and 2. Do not use the signs yet. At least not in my method. There might be methods where you would use signs. But as all I'm looking for are factors of 14 that subtract to the number 5. Okay, I found them. Now I have to figure out where the 7 goes and where the 2 goes. And the answer is the bigger factor, 7, goes with the sign of the middle term, which is negative. So the 7 goes there, the 2 goes there. So there are 4 very specific steps in factoring. You split up the x's. You determine both signs. You figure factors of 14 that add or subtract, depending on the sign in front of the 14, to the raw number that's the coefficient, the absolute value of it. And then you take the larger of those factors and you put it with the sign of the middle term. It's real simple. Those 4 steps you'll never go wrong with those 4 steps on a elementary quadratic, which this is.
Okay.
Okay. Now, since that's all equal to 0, what is my solution?
X -2 and x plus 7.
Okay, let's write it like this. Because we have to figure out what y is also for each of these x's. In other words, our solution set is going to be something like this. Let's see, that's -1. The solution set is going to look something like this. Okay? Well, there's an x and y value at that intersection point, and there's an x and y value at that intersection point. So I can't just solve for x. I haven't solved it. I got to come up with y also. Well, what's the y that corresponds to -2? In other words, there's a different y for each one of these. Use the simplest equation to solve for y.
So
what's the y that goes with the -2?
0.
Well, plug in -2 into this equation that I've circled and solve for y. That's all you do. It's real simple.
So 1.
Okay. Now give me the y that goes with 7.
So
Same equation.
right. So wait, what?
Same equation. I'm going to use the same equation I just used, only I got a different x this time. This time the x is 7.
Oh, okay. So 66 or hold on. Yeah, no, 64. Sorry.
Your calculator always. When we're doing a session, always have your calculator available. So what are my
Right.
solutions? By that I mean my two intersection points.
-2, 1.
Which is this one right here.
Right. And then 764, which is the one way up there.
And obviously I can't graph it on their graphing grid in any way, shape, or form. They keep giving us the same grid and giving us problems where the numbers are way off the grid. But that's right. Each solution has an X and a Y coordinate. And that's always when you have a system of equations that you're solving. You don't always have two solutions. Frequently, if you're solving a set of linear equations, in other words, if I have a line and another line that crosses it, well, then I only have one solution. But there's an X and a Y value on that one solution. So if it crosses it in two places, you're going to have two X, Y value solutions.
Okay.
All right. These look a lot harder than they are. Got just about enough time to at least get started on them. So it's a physics problem. It's projectile motion. It's when you throw something into the air, whether it's straight up and down or you throw it at an angle. If you got back and you throw a football, it's going to go in the form of a parabola. It's going to go like that.
Right.
So if they're giving us the height, that's h of t at any point in time, and this axis is time. So all I got to do is figure out how to graph that. Well, it starts out by saying write it in vertex format. Okay, let's do that.
So, so complete the square, right?
Yeah, this is supposed to be a t, not an x. So what's the first step in completing the square?
So,
Always think parentheses. If you remember parentheses as the first step, you'll never get it wrong.
right.
What goes in those parentheses?
-16 t squared plus 32 t.
Where's the 4 go?
Outside.
Okay, so that's what we're looking at. We haven't changed it. Now, there's a caveat to completing the square. You cannot complete the square until the coefficient in front of the t squared is 1. It's the only time you can complete the square. I cannot complete the square the way this is right now. I got to get the coefficient to be 1. How am I going to do that?
Divide by -16.
Factor out the -16.
Oh, yeah.
Same thing as dividing. What are you left with?
16 on the outside. Oh, yeah. Okay, and then
Negative.
t squared. Yeah.
Okay.
T squared minus 2 t.
Okay, now here's where I leave room to complete the square. And I know I'm always adding. So again, this line, same as that line, same as that line.
Right.
Every time you do a new row, make sure you haven't changed it. And by making sure, I mean, go ahead and multiply it back together again. You get minus 16t squared plus 32t. So we haven't changed it. Now complete the square in the middle. Or complete the square inside the parentheses, which is always what you want to do.
Right. So it's 1.
Okay?
Plus 1.
Now, how much did I just add to the right side of this equation when I wrote that 1 in there?
1.
No.
You subtracted.
That 1 is being multiplied by a minus 16. So what I really did was I subtracted 16 from each side, or from the right side of the equation. So I got to balance it by adding 16.
Okay.
Now, this is exactly the same as each previous line. So all I'm doing is manipulating it around so that I can put it in vertex format. So what's the final vertex format for height of this ball?
So, negative 16, t minus 1, and squared, plus 20.
Okay, cool. Now we got it in vertex format, we can graph it. Where is the vertex?
120.
Okay, if I make that 120, which way does this parabola open?
Down.
Okay, so it looks something like this.
Okay.
Now, it doesn't say if the ball was lobbed straight up into the air. The way I've drawn it, it looks like it has a little bit of curvature to it. It doesn't actually matter, believe it or not.
Okay.
In other words, I know how high is the ball going to get at its peak. In other words, the answer B. What's the maximum height of the ball?
20 feet.
Okay, when did it get there? On the time axis, the horizontal axis.
After
Not
1
after.
second.
Exactly, at 1 second.
At 1 second.
At 1 second, the ball hits its peak. It hits its vertex.
Okay.
Okay. Now, we're out of time, but to answer D, when does the ball hit the ground? What's its height going to be when it hits the ground?
0.
Okay, so make that 0 and solve that equation. And that will tell you when the ball hits the ground.
Okay.
Okay? So all of these projectile motion problems are pretty much the same. You put them in vertex format. That tells you where and when the height occurred. And then where it hits the ground is when the height is 0. All right, Demetrius. Let's see. So I won't be talking to you for a couple weeks at least.
Right.
I will let you contact me as to when to get started again. It'll probably be in January, but I don't know when you go back. Do you know what date you go back to school?
No, I'm not sure.
Okay. All right. Well, you have a good Christmas and New Year's, and good luck on your final. And I will probably talk to you next semester.
All right. Yep.
Demetrius, bye-bye.